Today we are going to derive Bernoulli's principle. Bernoulli's principle states that the total energy of the fluid while it's flowing in a conduit remains constant. Therefore, when the energies are manifested in the form of heads, that is pressure head, velocity head, and gravitational head, sum of all those heads remains constants. Constant. That is P by rho g, that is the pressure head, where P is the pressure, rho is the density, g is the acceleration due to gravity. V square by 2g, where V is the velocity, g is the acceleration due to gravity, and h is the height, that is the height of the cross section of the center of the cross section with respect to a fixed datum. The sum of all these three heads remains constant when a fluid is flowing in a conduit. Now we are supposed to derive it. The derivation of Bernoulli's principle can be done as follows. Let's consider a conduit in which we will take two cross sections. This is 1 1 dash, and there's another cross section 2 2 dash, and we will consider the fluid is moving in this direction. Let the pressure at this will be P1, velocity be V1, and height with respect to a fixed datum, say this one, this is H1. And pressure here is P2, velocity is V2, and height is H2. Now what we are supposed to find? We are supposed to find, or we are supposed to prove that P by rho g plus V square by 2g plus H is equal to constant. In other words, it means that P1 by rho 1, P1 by rho g plus V1 square by 2g plus H1 is equal to P2 by rho g plus V2 square by 2g plus H2 is equal to constant. That's what we are supposed to prove. So our motive is to prove P1 by rho g plus V1 square by 2g plus H1 is equal to P2 by rho g plus V2 square by 2g plus H2. That's what we are supposed to prove. Now, how to prove it? Now, we will use a theorem, that is work energy theorem. According to work energy theorem, the work done on a system is equal to change in energy that is being induced in the system. Now, work done on the system, that will be equal to pressure, that is the effective pressure responsible for moving the fluid, into change in volume, that we have discussed, P into delta V. So, according to work energy theorem, according to work energy, P into delta V is equal to the change in kinetic energy plus change in potential energy. This is the thing that we are supposed to use. Now, what is the effective pressure? The effective pressure should be, obviously, should P1 be more or P2 more? Obviously, P1 should be more. Because if the fluid is supposed to move in this direction, then P1 needs to be more. So we can write effective pressure is P1 minus P2 into delta V. P1 minus P2 into delta V is equal to, now the change in kinetic energy will be half of m, that is the effective mass delta m, v2 square minus v1 square. Half of mass into velocity square is the kinetic energy. So the change in kinetic energy will be half of delta m v2 square minus v1 square. Delta m may be the mass of the fluid that's moving in some time, delta t, plus what will be the change in potential energy? That is delta m g into H2 minus H1. H2 minus. Now we know that mass density is equal to mass per volume. Since density is equal to mass by volume, therefore I can say that delta V is equal to delta m by rho. Delta m by rho. So it implies P1 minus P2, instead of delta V, what will I write now? Delta m by rho. And then that's equal to, now I can take delta m common, because it's at both these terms. It will be v2 square minus v1 square divided by 2 plus g into h2 minus h1. Clear? Now this delta m and delta m will get cancelled. Now I will take g constant from these terms, but g is not present here, so g will come in the denominator. So I can write p1 minus p2 divided by rho is equal to g constant v2 square minus v1 square divided by, it will be 2g plus h2 minus h1. Is this clear? Now, where will this g go? It will go downwards. We will have, it implies p1 minus p2 by rho g is equal to v2 square by 2g minus v1 square by 2g plus h2 minus. Now all those terms that have the subscript 1, we will place it on the left hand side, and all those terms that have the subscript 2, we will place them on the right hand side. Therefore we will have p1 by rho g plus v1 square by 2g plus h1 is equal to p2 by rho g, because this is minus p2 by rho g, plus v2 square by 2g plus h2. That is what was the statement of the Bernoulli's principle. This is the easiest derivation of Bernoulli's principle that you will find on internet.